Stoichiometry is a section of chemistry that involves using relationship between reactants and or products in a chemical reaction to determine desired quantitative data. Example number 1. Ibuprofen is a covalent compound and the active ingredient in several popular non-prescription pain medication. What is the molar mass for this compound?
So our lesson this week is we're going to talk about stoichiometry. So stoichiometry. So this is our topic this week. So when we say stoichiometry, it is a section of chemistry that involves using relationship between reactants and or products in a chemical reaction to determine the quantitative data. So before we undergo to the balancing equation, we will first identify the different ways to get the correct ratio of a data or the desired data. So by this, we're going to get the molar mass, the moles, the mass, and also the molecules. So those are the things that we are going to solve. Molar mass, second is the moles, third is the molecules. So actually there is also a percentage composition. So this is the 4, and after that we will undergo balancing equation. So first we will discuss the molar mass, moles, and the molecules. So first is we're going to get the molar mass of a compound. For example, the water. So as we all know that a water has a chemical formula of H2O, which means that there is 2 atoms of hydrogen and 1 atom of oxygen. So how to get the molar mass of a water? So simple. So we're going to get or identify first the atomic mass of an element. And in hydrogen, we have 1. So, asa na to makuha ang atomic mass sa isa ka element or isa ka element sa compound? So, we must have our own periodic table of elements because all the atomic mass of an element is constant. So that's like the hydrogen. As you all know, hydrogen is 1 because it is the lightest element of all the periodic table or elements in the periodic table that are present. So while the oxygen we have is 16. So the atomic mass of hydrogen and oxygen. So by that we're going to multiply them. 2 times 1 is 2. Then 1 times 16 is 16. Then we add, then 2 plus 6 is 8, then 1. So this is now the molar mass of the water. So that is how we are going to solve for the molar mass of a compound. So for example, another example is, what if the ibuprofen is a covalent compound and the active ingredients in several popular non-prescription pain medication? So what is the molar mass of this compound? So according to our question, we are going to get the molar mass of ibuprofen. So last na to ng mga lesson, we already discussed how to get the chemical name or the name of a compound. So the ibuprofen, So, diba, as you all know that ibuprofen can be found in a pharmacy. And it is a pain reliever. So, the chemical formula of ibuprofen is C13H18 oxygen 2. So, this 13 presents, there are 13 carbon, 18 hydrogen, and 2 oxygen. So, atong problem diri is to get the molar mass of ibuprofen. So, to get the molar mass, C, H, and O. So, our carbon is 13, our hydrogen is 18, and our oxygen is 2. So, hindi siya nagtatapos yung pag-solve natin ng ating molar mass. So, to get the molar mass of the ibuprofen, we need first to get the atomic mass of each element. And our carbon is 12. Our hydrogen is 1. And our oxygen is 16. So, if you're going to check your periodic table, these elements, diba, dili man na siya 16 directly, pero gi-round off na ko siya. So, class, when we're going to solve the molar mass, i-round off na to siya, or 2 whole numbers, so that, pag atong mga quiz in the near future, or yung mga answers sa exam is, uniform. Kumbaga, we have the same result. So, 13 times 12, we have 156 grams per mole. And 18 times 1, we have 18 grams per mole. And 2 times 16 is we have 32 grams per mole. So we're going to add the 3 atomic mass of each element. So 156 plus 18 plus 32 is equivalent to 206. 206 grams per mole. So that is the molar mass of ibuprofen. So for number 2 example of molar mass, calcium phosphate is an ionic compound and a common anti-caking agent added to food products. So what is the formula mass of calcium phosphate? So calcium phosphate class is in need in order to make or create a food product. It is called as the anti-caking agent. So what are we going to solve is also to get the molar mass of the calcium phosphate. So a calcium phosphate So this is the chemical formula of calcium phosphate. So, yan yung ating kukuhanan ng molar mass, the calcium phosphate. So, just like what we've done to example number 1, yun din yung gagawin natin for our number 2. But first, we cannot padayon sa atong molar mass without determining first the coefficient of each element. So, this is 2 times 4 and 2 times 1. So, it becomes So, ang P magiging 2. Then, our oxygens become 8. So, minsan, para hindi kayo mahirapan. Lalo na yung mga hindi nyo masyadong makuha agad-agad. Paano naging 2 yung phosphorus at paano naging 8 yung oxygen. So, ana lang na ang ihang way class. So, now, let's solve for the molar mass of calcium phosphate. Ca P and O. So, our calcium is 3. Our phosphorus is 1 times 2, 2. And our oxygen is 4 times 2, so we have 8. Multiply by their atomic mass. So our calcium has 40. And our phosphorus is 31. And our oxygen is 16. So, by that, we can now solve the molar mass of a compound. So, 3 times 40, so it is 120. So, for phosphorus, 2 times 31, so it is 62. And for oxygen, 8 times 16, so it is 132. 128. 28. So we will add the 3. So we're going to add the 3, the atomic mass of each element. So 2 plus 8, so it is 0. So carry 1, so 6, so 10 becomes 11. So carry 1, then comes 3. So our molar mass is 310 grams per mole. So that is the molar mass of calcium phosphate. Second one is we have the mole. So how do we get moles of a compound? So simply, so we're going just 2 grams times mole over grams, so that you can cancel grams, then matitira na lang is the mole. So yan lang yung gagawin natin during the process of getting the moles. So just like this example. So according to the nutritional guidelines from the U.S. Department of Agriculture, estimated that the average requirement for a dietary potassium is 4.7 grams. 4.7 grams. And what is the estimated average requires of a potassium in moles? So which means we're going to solve for the moles of a potassium that is required, or estimated average required. So we have our mass, which is 4.7 grams. And how could we get, or paano nato makuha ang mole sa potassium? So since naa naman ato ang mass for the potassium, so we're going to get the molar mass or the atomic mass of the potassium. So a potassium has a molar mass or atomic mass of 39 grams per mole. 39 grams per mole. So that is the atomic mass of our potassium. So kanang 39 grams per mole, mao na atong gamiton to get the mole of our potassium. So 4.7 grams multiply to 1 mole over 39 grams. So, makancel out na to ang grams. Ang mabilin is the mole. So, 4.7 divided to 39. So, it is equivalent to 0.12 mole of potassium. So, this is our mole of potassium. So, inala lang ka. Dali. So, always give together kay grams ang number of atomic sa isa ka compound or isa ka element. And mole, always gina siya 1. It's either we're going to get the mass or we're going to get the mole of a compound. So, for number 2 example, So it is also going to solve or going to get the mole of a compound. So ganina ato lang gisolve is the mole of a certain element. For number 2, we're going to get the mole of a certain compound. So beryllium dioxide is a light metal which is used to fabricate transparent X-rays. So how many moles of a beryllium dioxide are in thin fuel window in 3.4 or 3.24 grams. So we have a mass of beryllium dioxide which is 3.24 grams. So how we are going to get the moles of beryllium dioxide? So for our computation, so first we're going to get the molar mass of beryllium dioxide. So B, E, and the oxygen. So we have 1 and then we have 2. So the atomic mass of the beryllium is 9. And for oxygen is 16. So 1 times 9 is 9 and 2 times 16 it is 32 grams per mole. So all we have to do is to add 9 plus 32. So it's equivalent to 41 grams per mole. So we have now our molar mass of the compound. So we can now proceed getting the moles of a compound. So write down the given, which is 3.24 grams multiplied to 1 mole over 41 grams. So cancel out the grams. So mabilin is our mole. So 3.24 divided to 41 grams. So divide. So 3.24 divided to 41. So our answer is, yes, it is 0.08 mole. So that is our mole for the beryllium dioxide. So atong unit is our mole. So do not forget, class, talaga to write the unit of each or your final answer. There's tendency na tama imuhang number pero mali imuhang gigamit na unit. Third type is we have the mass. So we done na ta sa molar mass, tapos na ta sa mole. So we have now the mass. So ang ano sa mole of mass is the ano lang, ang pag-cancel sa unit. But the process is almost or also the same. So for example, if we're going to get the mass or the grams of a compound, so mole multiply to grams over mole, so that makancel na to ato ang mole and then mabili na lang is our gram. So just like this example. So what is the mass of 0.4440 mole of hydrazine? So we're going to get the mass of the hydrazine, which has a 0.443 mole. So first, same process with the mole. We're going to get the molar mass. Then after that, we're going to solve for the mass of a compound. Molar mass first, so of hydrazine. So hydrazine is NH. So hydrazine, nitrogen has 2 atoms and hydrogen has 4. So write or find their atomic mass. So our nitrogen has 14 and our oxygen has 1. So all we have to do is to multiply the 2. So 2 times 14, we have 28 grams per mole. And our hydrogen, 4 times 1, we have 4. Then add. So 28 plus 4 is we have 32 grams per mole. So we have now our molar mass for hydrazine. So we can now continue to solve for our mass. So here we have the given, which is 0.443 mole. So we have our molar mass, which is 32 grams per mole. So 32 grams over 1 mole. So cancel out ang mole. So pag ang mass gani ang kwaon class, sa taas ang gram, sa baba ang mole. Pero pag ang mole ang pangitaon, sa taas ang mole, sa baba ang gram. So 0.443 multiply to 32. So our answer is correct. It is 14.28 grams. 14.28 grams. So this is now our mass for hydrazine. So that is how we are going to solve for the mass and also for the molar mass. So that's the reason why una nato nga part ganina ang solve is the molar mass, para while we are solving for the moles and mass, dili na mo mahirapan kasi you already know naman the process on how to solve for the molar mass of a compound or an element that is present in a given formula or a given problem. For number 2 example of mass, a recommended daily dietary allowance for vitamin C for children aged 4 to 8 years old is 1.42 times 10 negative 4 mole. What is the mass of this allowance in grams? So we are going to get the mass of a vitamin C or the mole of a vitamins. So we have our, so first we are going to get the molar mass before we are going to solve for the mass. Here, so we have the O. So carbon is 6, hydrogen is 8, and our oxygen is 6. So multiply by their atomic mass. So carbon times 12, hydrogen times 1, and 6 times 16. So 6 times 12, it is 72 grams per mole. So 8 times 1 is 8, and 6 times 16 is 96. So 72 plus 8 plus 96. So i-add pa rin natin. So is equivalent to 176 grams per mole. So we have now our molar mass of a compound. So since we have our molar mass, we can now solve for our mass. So our given, we have 1.42 times 10 raised to negative 4 grams multiply to, it is mole, mole, multiply to 176 grams over 1 mole. So here we can now cancel out our mole. So what is the answer? So when we say raised to negative 4, it is, for example, 1.42. So 1, 2, 3, 4. So here, it is negative. So 1.42 times 10 raised to 4 multiplied to 176. Yes, our answer is 0.0250 grams. So for our last topic, we have the molecules. So we're going to use Avogadro's number, so which is a constant number with 6.002 times 10 raised to 23 molecules. So this is what we are going to use if we are going to get or going to solve the molecules of a given compound or a given problem. So just like this one. So a packet of an artificial sweetener contains 40 milligram of saccharin. How many molecules of saccharin are in 40 milligram sample? How many carbon atoms are in a same sample? So which means that this problem is we are going to get the molecules. So dalawa atong kuhaon diri, the molecules of saccharin and also the number of molecules of a carbon. So which means duha ang ato ang kuhaan og molecules. The molecules of saccharin and the molecules of a carbon that is present in a compound. So we have 40 milligram sample. So since it is a milligram, we're going to first convert. So our step 1 is we're going to convert milligram to grams. So we have 40.0 milligram multiplied to 1 gram over 1,000 milligram para makancel out na ato ang milligram. So 40 divided to 1,000, so it is 0.04 grams. So we have now our grams. So na-convert na nato. So second is we're going to get the molar mass of a compound. So muna ni siya ang second step, going to solve for the molar mass. Molar mass. The molar mass of saccharin, so which has carbon, hydrogen, nitrogen, oxygen, and sulfur. So these are the elements that are present in this compound. So carbon has 7 atoms, hydrogen has 5, nitrogen is 1, and oxygen is 3, then our sulfur is 1. So multiply by their atomic mass. So each of them, kailangan na to i-multiply sa ilahang atomic mass. So 7 times 12, 5 times 1, nitrogen is 14, oxygen is 16, and our sulfur is 32. So, i-multiply natin. So, 7 times 12, it is 84. 5 times 1, it is 5. Our nitrogen is 14. So, 3 times 16 is 48. And 1 times 32 is 32. So all we have to do now is to add the atomic mass of each element. So 84 plus 5 plus 14 plus 48 and plus 32. So the molar mass of the compound is 183. 183 grams per mole. So we have now the molar mass of our compound. So since we have now our molar mass, we can now solve for the molecules of the compound and the molecules of the carbon. So for step C, we can now solve for the molecules of saccharin. So since we have our molar mass of the compound, so and also we have our mass, so 0.04 grams multiplied to 1 mole over our molar mass, which is 183 grams, and then multiply to our Avogadro's number, which is 6.002 times 10 raised to 23 molecules over 1 mole. So, cancel out the grams, cancel out the mole. Then, ang mabili nato is our molecules for the compound. So, 0.04 divided to 183 multiplied to 6.022 times 10 raised to 23. We have now 1.32 times 10 raised to 20 molecules. So this is now the molecules of our compound. So since you have our molecules for our compound, we can now then solve for the molecules of carbon. So as we all know that a saccharin has a chemical formula of C7H5NO. So that is the formula of saccharin. So our carbon has 7 atoms. So by using the molecules of our compound, we can now solve for our molecules of our carbon. Carbon 7. So 1.32 multiply to 1 C7H5NO3S molecule. We can now cancel out our molecule, and then ang mabili nato is our atom. So because the question pala is how many carbon atoms. So we're going to solve the carbon atoms of the carbon. So we have 7C. So ang mabili nato is our atom. So 1.32 times 10 raised to 20 multiplied by 7 divided by 1. So we have now 9.24 times 10 raised to 20 C atoms. So the C stands for the carbon. So this is now our atom of carbon in a compound. So if we're going to solve for the molecules, this is the process, the letter C process. But if we're going to solve for the atom of the element in a given compound, so this is we are going to use. So first you're going to get the molecules in order for you to get the atom of a element that is needed to be solved. So for our second example is we're going to solve for the molecules of a compound which contains 13.4 grams of sugar. So our sugar, so is C12, H22, oxygen 11 that contains 13.4 grams. So we have our mass which is 13.4 grams. So first is we're going to get the molar mass of a compound. So do not forget, if the given is grams, you need first to solve for the molar mass. Pero if the given is already mole, so no need na. So pag mole na gani yung given, for example, this is mole, so diretso na. So mole multiply to the molecules. So diretso na siya para makuha ang molecules. Pero kung grams ang given, then you need to undergo the long process, which is to solve for the molar mass of a given compound. So 12, 22, and 11. So our carbon is 12, oxygen is 1, and our hydrogen is 1, and our oxygen is 16. So 12 times 12, 144, 22, and 16 times 11 is 176. So i-add na to ng tatlo ka atomic mass sa atong element. 144 plus 22 plus 176, it is 342 grams per mole. So naa na tay molar mass. So we can now solve for the mole. So 13.4 grams multiplied to 1 mole over. So 13.4 grams multiplied to 1 mole divided to our molar mass, which is 342. So, makancel out ang grams. Mabilin is our mole. So, 13.4 divided to 342. So, the answer is 0.39. Correct. 0.39 mole. So, that is our mole. So, since we have our moles, we can now proceed to solve for our molecules. Kaya ang problem na to, main problem is to solve for the molecules of the given problem. So, 0.39 mole multiply to 6.022 times 10 raised to 23 molecules over 1 mole. So, cancel out the mole. Mabili na to is our molecules. So, don't forget the unit, everyone. 0.39 multiplied to 6.022 times 10 raised to 23. Our answer is, yes, it is 2.35 times 10 raised to 23. So that is now our final answer. So this is the molecule of a compound, which is the sugar.